Hey everyone, it's Miss Casto. Today we're starting topic 15, geometric measurement, understanding concepts of angles and angle measurement. So we're going to be doing lesson 15.1. If you have your book, you can get it out. If you are online with me, you can get online under your Pearson Realize account, or you can just follow along. And remember, I'd like you to always try the problem. Pause it after I explain it, try it on your own, and then come back to check out the answers. So in 15.1, we are talking about lines, rays, and angles. Your I can statement for today is I can recognize and draw lines, rays, and different types of angles. We're going to the solve and share as always. I'm going to try and get you with a goof and see if you can guess what happened. Where did I go wrong? So here is the problem. A right angle forms a square corner like the one shown. Draw two angles that are open less than the right angle. Solve this problem any way you choose. There's also a math tip to help us out up here. The closer the sides of an angle, the smaller the angle measurement. So these are the sides of the angle. The closer they are together, the smaller the angle is going to measure. So if I want it to be smaller than a right angle, which is this one shown, so that a box can be drawn in the corner, I need to draw mine smaller than the right angle. So if I come out here and I make this one smaller, there is a smaller angle. Did you catch it? That's not smaller, that's bigger. So we need to go and erase this and try again. I'm going to delete my screen here. Give me just a moment. And I'm going to come inside of this right angle and I'm just going to draw it smaller. So I'm going to start here and I'm going to use the bottom of this right angle as the start of this angle. So this one is smaller than this right angle. And then if I did this, I have this angle here. And then I also have this angle here, which is also smaller than this right angle. So with one line in the middle, I've divided this right angle into two angles that are smaller than 90 degrees. And I keep saying 90 degrees because a right angle measures 90 degrees. So let's take a peek at the look back reasoning. Draw an angle that is open more than a right angle. And I got you with a goof on that one. So if you have a right angle, let me scooch my toolbox down, maybe that will work. If I draw my right angle, remember that's one that's 90 degrees, you can make a square in it, in the corner of this angle. So I'm going to draw one that is bigger. So I'm going to go. Now, this angle is bigger than the right angle. So we can see that happening. Okay, here's your visual learning. And at the request of some people, I'm going to play it. It's 2 minutes and 46 seconds long. You can skip through this part of the video if you've already watched it, but I'm going to play it for those of you who are watching the video and have not seen the visual learning animation.
What are some common geometric terms? Think about this question during the lesson.
My volume doesn't want to work for you, but I'll play it. It says, I'll just read it to you as they play it, and it'll be like my voice instead of theirs.
What are some common geometric terms?
Think about this question during the lesson. Point, line, line segment, ray, right angle, acute angle, obtuse angle, and straight angle are common geometric terms. A point is an exact location in space. This is point Z.
This is point Z. A line is a straight path of points that goes on and on in opposite directions.
This is line AB. A line segment is a part of a line with two endpoints. This is a line segment GR. And you can notice that this line AB is marked with arrows. That's because it's not a segment. It doesn't have a beginning and it doesn't have an end. It's going to go on forever in the left direction and forever in the right direction. GR does not have arrows. That's because it is a line segment. You can see it's marked by 2 points here. It has a definite beginning. It begins at G and it has a definite end. It ends at R. It's not going to go on any farther in either of those directions.
GR. A ray is a part of a line that has one endpoint
and continues on forever in one direction. Lines and parts of lines are named for their points. A ray is named with its endpoint first. What is a name for this ray? So before I tell you, remember it has a definite endpoint here, but it has an arrow that's going to continue on in that direction. Since a ray is named with its endpoint first, you're going to name it, correct, NO.
For this ray.
Select your answer.
Oh, look, they have no or on. We said we're going to start with N first and then go to O. You would be correct. This is ray NO. An angle is formed by two rays that have the same endpoint. Angles are named with 3 letters. They share endpoint of the rays is the center letter. The other letters represent points from each ray. So this one's called ABC. You start here, ABC.
Angle ABC.
ABC is a right angle. A right angle forms a square corner. DEF is an acute angle. An acute angle is open less than a right angle.
Angle GHI
is an obtuse angle.
An obtuse
angle is open more than a right angle, but less than a straight angle. JKL is a straight angle. A straight angle forms a straight line. Now you can try it out and drag the slider to see different types of angles. So if you have this on your computer, you'll be able to practice with it a bit. So if we continue dragging it, it says ABC is a straight angle. Angle ABC is an obtuse angle. Angle ABC is a right angle. Angle ABC is an acute angle. So now that you know a little bit about rays, angles, obtuse angles, and straight angles, let's see if you can complete each figure to show the given angle. So this is where you would pause the video, try it out yourself, and then come back and check it with mine. An obtuse angle is bigger than a right angle, so it needs to go out farther than a square. So if this was your square, it needs to come all the way out. This would be the right angle, so it needs to be bigger than that. A straight angle would be just a straight line. Then an acute angle needs to be smaller than 90 degrees. So here's 90 degrees. It needs to go smaller than that. It could be here, it could be there. Either of these two lines would work as an acute angle. And a right angle needs to make a square. So it needs to go straight out to the side. You could also do it straight out to this side too. Either one would work. Now we have guided and independent practice. So take a look. It says, do you understand what geometric term describes a part of a line that has one endpoint? Draw an example. So stop the video, try it on your own, and then come back to check it. I'm going to move this down so I can draw one for you. If it has one endpoint, it's going to have, remember, we demonstrate a point with a little dot. One endpoint and the other one's going to keep going on, so it needs to have an arrow. What geometric term does this describe? Well, it's a ray. Number 2 says, what geometric term describes a part of a line that has two endpoints? That's one endpoint, two endpoints. Draw the example and name it. What term is this? This is correct. That's a line segment. This might be easier to put in the text box. A line segment. Number 3, what geometric term describes an angle that forms a square corner? So we have an angle that forms a square corner. What is that called? That is called a right angle. Right angle. Now for 4 through 7, you're going to use geometric terms to describe what is shown. So we're going to use a text box for this. Remember, I want you to do these on your own, then come back and check them with me. So number 4, I can't see it. This is going to be a line segment PX. So I'm going to draw it like this. This is how you're going to say it. You're going to say line segment PX. This is going to be angle PQR. And you need to tell what kind of angle it is. And since it makes a square in this corner, it's a right angle. Number 6 is a ray because it has one endpoint and the other one has the arrow. So it's going to be demonstrated like this. And we're going to call it, remember, we start at the endpoint BY. So ray BY. And then number 7 is an angle. So we put the angle at the beginning and we call it LMN. Oops. LMN. And we're going to name what kind of angle it is. If it's a right angle, it makes a square. If it's bigger than a right angle, it's obtuse. If it's smaller than a right angle like this one, we're going to call it an acute angle. Okay, independent practice. Numbers 8 through 11, you need to use geometric terms to describe what is shown, just like we did up here. And then for 12 through 15, draw the geometric figure for each term. So first draw a line segment, then draw a point, then draw a ray, then draw a line. I'm going to let you do those on your own and check them with someone that is with you at home. I'd like to, for a few moments, go over the problem solving. So numbers 16 through 18, you're going to use the map of Nevada, write the geometric term that best fits each description. Draw an example. Be precise. The route between two cities. So from here to here. And I think this might work best if I make this a little bit bigger for us if I can. Whoops. There we go. The route between two cities. So from, you can pick any city. So from here to here. Well, it has a dot here and a dot here. The route between these two cities would be what? What would we call that? What geometric term best fits that description? Pause the video, work it out, and then come back to guess. If you guessed a line segment, you would be correct because a line segment has a point, a specific ending and a specific beginning, and these two cities do. The cities, what geometric term best fits those? This city, this city, this city, and this city. Pause the video. Did you call them a point? You would be correct. Now this number 18 says the corner formed by the north and west borders. So north is at the top, and then west is on this side, these borders. So this to this. What would we call that? Oops, I guess I should darken my line so you can see it pretty well. You can pause your video. Okay, are you back? Did you call it a right angle? If you did, you would be correct because this, the middle, forms a square. Number 19, write a definition for right angle. Draw a right angle and give 3 examples of right angles in the classroom. Now you are not in the classroom right now, but you can try and find an example of a right angle somewhere in your house. Pause the video and bring it back with you to check it with what example I have. I have a book, so I have this line and this line. They form a square right here in the middle, so this would be considered a right angle. I also have an envelope here. My envelope forms the same right angle here in the corner. It has 4 right angles. 1, 2, 3, and 4. I also have a card here, and my card has 4 right angles, just like my envelope. So there are my 3 examples. I hope you found 3 examples for yourself. Number 20, this is the higher order thinking one, so this is going to make you think a little bit harder, and it might have a couple of steps to it. But you can easily solve problems using our problem-solving formula. Remember, first, you want to find the question. What is it asking you? Nina says she can make a right angle with an acute angle and an obtuse angle that have a common ray. Is Nina correct? Draw a picture and explain. First, I'm going to find the question. Is Nina correct? She's saying that she can make a right angle with an acute angle and an obtuse angle. And then they want you to draw a picture and explain. So an obtuse one, I want you to, before I explain anything else, pause the video, see if you can find a way to draw the picture and explain what's happening here. Then come back and check with me. Okay, so if I have an obtuse angle, that means it's bigger than a right angle. Okay, if I have an acute angle, that means it's smaller than a right angle. Well, if I put an obtuse and an acute one together, am I going to get a square? No. So I can draw a 120 degrees obtuse angle, like that one would be like this one, and I can draw one that is about 30 degrees. That would equal 150 degrees. That's more than 90, so I know that that would not work. Okay, number 21. Which geometric term describes angle HJK? So HJK. Is that acute, obtuse, right, or straight? If you said it's a straight angle, you would be correct because that is HJK. That one's a straight line, so it's a straight angle. Number 22. Lisa drew 2 rays that share an endpoint. Which of the following is Lisa's drawing? Now remember, if it's a ray, it has an endpoint and then an arrow at the end of the other side to show that it's going to keep going on from there. So let's take a peek at these. We're looking for two rays that share an endpoint. Okay, these ones share this endpoint. Oh, these ones aren't even connected, so we are not going to choose that one. That one is not going to be an option. This one shares an endpoint, and these ones share an endpoint. Now remember, the key word is they said rays, two rays. This one has two endpoints at the end. That means those are line segments. From here to here is a line segment. From here to here is a line segment. This one here has a line segment here and a ray here. Well, that can't be it because it has to have two rays. So your only option that works is A, because it has a ray here, an endpoint, and then an arrow on this side. That's one ray, and then an endpoint here and an arrow here. That's another ray. So A is the answer. Now, for the rest of this lesson, you have a practice buddy that I assigned to you on Pearson, and you also have a quick check to complete. Have a great day, and we'll see you again tomorrow.